Okay, guys. So let's start. What we're going to be doing today, guys, is basically try to present a couple of ideas, a couple of models, how they work, how you're going to be working for your project, and and a way to make programs in a really easy way. Okay. So let's take a look. Last time, guys, we did a Cobb-Douglas utility function. So we work with a Cobb-Douglas. This is a very useful utility function used in economics. And now let's do something. There is a model that is called the two-period consumption model. The two-period consumption model. Okay. So now my utility, guys, is going to be intertemporal. So I will have two periods of time. I will have T0 and I will have T1, and I will decide what to consume in each period. Okay. So that's why it's called intertemporal consumption. So let's assume that my utility is given by log or ln, yeah, log of consumption, consumption at period 0 plus a factor log of consumption at period 1. Okay, and the only condition that we have is my subject to, basically that my consumptions at period 0 plus my discounted consumption of period 1, discounted at a given interest rate, must be equal to my income. So now this I represents income. Remember, when we have cash flows, guys, the future needs to be discounted. Okay, so that's why we do C1 divided by 1 plus R. So R is my interest rate. What is beta, guys? Beta simply is my discount factor. So beta is my how much I want to sacrifice today for consuming tomorrow. Okay, that's it. It's a very simple model. And what we try to do is we try to maximize this function given an interest rate and given a beta. That's all we'll try to do. Got it? So what we try to find is C0 and C1 given an interest rate, given a level of income and given the marginal rate of substitution between time. The larger B, guys, this implies that you prefer to sacrifice current consumption for future consumption. Make sense? The larger R also implies that. So if the interest rates in the banks are larger, so you're going to be more willing to sacrifice or to save now to consume in the future. Got it? So that's basically the basic idea. Can you open the file? Let me see which file here. Can you open the file? Let's go to MATLAB. Two-period consumption. Open the file, guys. I'm giving you starting values. Assume that my income is 100. Assume that the bank interest rate or CD, for example, is 5%. My beta is 0.95. My discount factor is 0.95. And then analyze the model. Let's say 2-3 minutes to analyze the model, understand the model, and see what you're producing.
Professor, I don't see this file inside the media fund.
Two-period consumption. You don't see that? Let
Yeah,
me
I don't
check.
see it.
Let me check in the send documents. Give me 1 second. Material for today is ISLM, dynamic. Oopsie, you're completely right. So
Yeah.
uh, let me send you more files now. Give me 1 second. So what's this one here? Give me 1 second. I need to complete the screen. So this is two-period consumption. Guys, I'm sending you 4 more files. Can you have a couple of minutes, download them, and open the first one that is called uh, open the first one that is two-period consumption.m. Okay, do you have the file, guys?
Yeah.
Yes.
Okay, perfect. Open that file and remember the model looks like this. So basically you need to identify this function. This objective function, the utility function, you want to maximize this one here, and my condition is this one here. One more minute, guys, and then we move because we need to do a lot of things now. Okay, guys, so let's take a very quick look. So my model is this one here. Remember why I'm using this one here? Because I will optimize this one. Okay, so my utility function is this is a name, is going to be, why I'm writing the negative guys here? Why I'm writing a negative here? Someone. Guys, why I'm writing a negative in front of a function?
That the minimum?
Yes, because remember the function, the functions, every program they don't maximize, they minimize. Okay, so remember that every function that we have in Python, R, MATLAB, or any other program, the functions are written for minimization of something. But what I want is a maximum. And remember, this function here is the log function, like the Cap Douglas more or less. So they are positives. So they are going to maximize the value. So in order to remember, the opposite to maximize is minimize. And what we do is we simply change the sign of the function. We did this last class, guys. Okay, it's a trick only to allow to find a maximum. Got it? We did that. We did this last class, guys. When I show you one function that was going up, let me. So remember, just for you to remember, if we have a function, last class we worked with a function like that. You remember? And I wanted to find this maximum here. So in order to work with MATLAB minimization functions, what we did is, okay, negative of this function, sorry, it will look like, yeah, it should look similar. This is my zero line. Makes sense to you? So my graph doesn't look exactly the same, but this is simply that if this is f of x, this one here is minus f of x. Got it? So if I find the minimum here, what I'm doing indeed is I'm finding the maximum here. Once I find this point here, it's going to be the same point. Do you agree, guys? Once I find this point here, well, sorry, this point here, I simply use this point here to find the maximum that is given by this y here. Everyone understand this part here?
Yes.
Okay, perfect. So let's go here very quickly. Then I will. This is going to be my optimal my objective function. My conditions are 1 plus r. So remember, this is c1. My coefficient for c1 is going to be 1, and my coefficient for this part here is going to be 1 over 1 plus r. This must be satisfied. And so remember, this part here is called a, and this part here is called b. So what I want is b. So what I'm saying is that my restriction should satisfy condition b. Now I do lower bounds because I'm going to use a fmin con. Remember that fmin con allows us to work with restrictions, but we need to always impose lower limits, and we need to give it, starting initial guesses. Then we do the conditions, sorry, the setting of the fmin con. So I will use the fmin con, and I don't want to display anything. I just want to run the optimization. Okay, so I will find my C optimal and my maximum utility. What I will do is I input the utility function that I have written here, my starting values and my limits and my lower bound. And options, simply I'm saying use fmin con, don't display anything. And then I'm simply printing the results. That's what we are doing here. So let's run this one. And let's see what we have. My two-period model, my optimal C1. Well, C1 is what I wrote C0. And my optimal C2 is this number here. So basically it means, guys, that I will consume basically half and a half. Do you agree? If my function is this one here, I will eat basically half and a half. And if I replace these values in my function, so it's going to be log of 5128 plus 0.95 log of 5115, the value that we're going to find is this 7.6754. This is my maximum utility given this function, this function and these restrictions. Okay, make sense? So let's do another function. So now let's add savings to your equation, guys. So my utility function, so two-period model, we continue with the two-period model. We are adding savings. Okay, so the people is going to start saving. So my utility function is going to be the same. I define my utility function to be the same. So guys, when I say log, it's indeed ln, okay, the natural log. But now what I will do is I will write the following condition. So C0 is going to be equal to 1 minus t I minus s. So let me explain what is this one here. T represent taxes. So what is 1 minus t, guys? This is what is left after taxes, correct? Agree with me? So if taxes are 20%, 1 minus 20%, 80% is what I keep from what? From my income. This is my income. And from this part here, so this is my disposable income. All this part here, guys, in economics is known as disposable income. So this is the money that I have after paying taxes. And from this disposable income, I will not spend everything. I will spend my disposable income minus the saving that I decide. So this is the consumption at period 0. Now, what I will consume at period 2 or at period 1, what I will consume at period 1 is going to be simply what the bank pays me for my savings. Okay, so my conditions are, I want to maximize, again, this one here, subject to two conditions. That what I consume now is my disposable income minus my savings, and what I will consume in the future depends on the interest rate and the amount of money that I have saved. This looks more or less like a pension fund, okay? A lump sum, one period pension fund. Do you agree? I save $100 now. I deposit this for, let's say, for a 10%. For the next period, that's what I have. Make sense to you guys? So if we put some numbers here, just imagine my C0 can be 1 minus 0.2. I'm doing an example. Imagine that I earn $10,000, and then I decide to save. So this is what? It's going to be 8,000. I decide to save $2,000. So what is my consumption at time 0? It's going to be $8,000 minus 6. I will consume $6,000. And now assume that in period 1, what I will be able to consume is basically, let's assume that the interest rate is 0.1, and I have saved $2,000. So how much I have for consumption in period 1 is going to be 2,200. So this is what I'm saying, guys. Okay, this is an example. But what we try to do is we try to find the values C0 and C1 given the taxes, given my income, and given my interest rates that are present in the market. What is the optimal C0 and C1? Make sense to you guys?
Yes.
Okay, so now analyze your MATLAB file that is called two-period consumption 2. 3 minutes to analyze that. Let me show you first this one here. Should be this one here, two-period consumption 2. 3 minutes to analyze. Okay, 1 more minute, guys. Okay, guys, so let's take a look to what happens here. So this function does not only optimize, but it does a beautiful plot. Okay, the same. I need to have I, R, theta, and now tau. Tau is my tax, my t. So I say 20% tau. Take a look. Again, I have a negative here. And this is my function, log of 1 minus tau I minus S. So this is my C0. And C1 is 1 plus R times S. Okay. So I have limits. I want my limit bound to be 0. Nothing can be negative. And my upper bound, guys, is basically what I can spend, my disposable income. I cannot save more than my disposable income. Do you agree? I will start with a initial guess of 10. And I'm using fmin search here. Why? Why I'm not using fmin con here, guys? Guys, why I'm using fmin search and not fmin con? Someone. Do you see a restriction here? Sorry, do you see here some restrictions on my such as do I see these conditions here, guys? Where do I see these conditions? These restrictions, where do I see them? If you take a look to the previous program, the restrictions were here. I have A and I have B. But in this case, I don't have these restrictions. Why? Because the restrictions, guys, have gone into the equation. Do you see this one here? Sorry, this one here. Do you see this part here? 1 minus tau times I minus S. This is your C0, right? What I have done is I have replaced in the restrictions on my objective function, disappearing technically my restrictions. When I have an unbounded, unrestricted equation, guys, the command to use is fmin search. Okay, once I do my fmin search, I'm telling, just in case my variable is S, in this part here, what you need to be using is S as variable, and I give you my starting point. And then once I have this value, what I will do is I will find the optimal S that I'm computing here. I want to be sure that it is between these bounds. It's between 0 and 1 minus tau. So what I do is the minimum of my optimum and my upper limit. Do you agree? So if the optimal is larger than my upper limit, I use my upper limit, my disposable income. Imagine that I have my opt-S is the minimum. And then from this one here, I select this one, this number here, that should be positive, or 0. If this number is negative, I will choose the 0. Make sense? And then you simply start building up the things. You start building up my optimal C1, my optimal C2, and then what is my maximum utility. And this is going to be displayed here. And then, guys, what I have created here is basically a function, a 3D function. You see, I'm using surf. We did this in the past. You know how to use the surf. Well, we haven't used the color map. The color map is you just do help, and it's going to basically show you everything that you need to know. And we have done also plot 3. So everything that we have done here, guys, is known by you. So let's run this program. I put D here with a bullet here just to stop and analyze the results. Here we go. So here are the results, the numerical results. Let me. So these are my results, guys. So this implies that given these conditions, given these starting values, what is optimal for me is to save 38.97. So this implies that I will consume 41.03. And how is my optimal consumption? How do I obtain this one? Here is simply my 38.97 times 1.05. You obtain your 40.92. Then you replace these values in your utility function, in this one here. And then you obtain the maximum utility for you is going to be 7.24. Makes sense? Do you understand what we're doing? Guys, are you with me?
Yeah. This
Okay,
makes sense.
perfect. So let's take a look to the graph. We have a 3D graph, guys. So I have current consumption. This is today. And this is the future consumption. You can see, guys, if I simply see the utility function and current consumption, I have my utility function, the regular utility function. So basically, if I turn this more and more and more. Yeah, here we go. Do you see? This is my consumption today. You see my mouse, right? And then you see my consumption in the future. both of them provide me a level of utility given by the utility function here. So remember, when we try to maximize, is try to find the combinations of C1 and C2 in such a way that my utility function is the top, is the maximum. Got it? And then if you click on this one here, just click there, you can see the exact values. Well, it's not exact value, this one. I think it's this one here. Yeah, this is the one. So this implies that today I need to consume 41. So this implies that I need to save 38.97. And in the future, multiply by 1.1 what's that? 1.05, I will obtain $40.92. What is the maximum utility I will get is 7.24. Can you be sure, guys, that you get this function, that you are able to see this function?
Yeah. Yep. Yep. Got it.
Perfect. Questions? You can, of course, play with that, right? So another way of seeing this stuff, I think this is the best way to do that. This is the best way to do that. Okay. Questions, guys? Now, guys, I will show you something more advanced. You don't need to read everything, but I'm pretty sure you can understand that. Can you go savings and policy simulation? What I'm adding here, guys, and this is something that you need to do in your programs. We're going to create a UI figure. Okay, this is the way you're going to create a UI figure. We're going to add some sliders. We're going to, add plots, etc., etc., etc. And what we're going to be doing, guys, is we're going to use my function. This function here, that is basically my model. It's the same model as the model I have used before. Okay, and these are simply coloring, blah, blah, blah. Don't pay a lot of attention here. Can you run this one here and see what happens? One minute for you to run. Okay. Let's run this one here. So again, I have the optimal, but take a look to this cool thing, guys. Now you have C1, you have C2, you have the utility, you have the optimal utility here, the one that we have found already. But this is based on specific numbers. Remember, I said that that the taxes are 20% and my interest rate is 5%. Remember, this is part of my my assumptions here. 100. Where's my R? I started my R for 20. Where is this one? Oh yeah, beta is 0.05. So 1 minus beta is my interest rate. R, 5%. And then what you can see here with this graph here, guys, is take a look to what happens. If I change, imagine that the interest rate is going up. Okay, let's say to 10%. So now what happens? Do you see, guys, do you see what is going on here? Is that as soon as the interest rate goes up, so for you, it's better to sacrifice more money today for saving in the future. Make sense to you? Guys, make sense to you or not?
Yes.
Yes. Okay. So now imagine that, okay, I will return this to 5% just to be in our equilibrium. Now let's assume, guys, that the government decides to decrease the taxes 5% more. So let's go to 15%. Do you see? In this case, the taxes affects together our current consumption and our future consumption. Why? Because taxes determine what is my disposable income. Make sense? So if taxes decrease, so let me check here. If taxes decrease, what happens with my disposable income? It's going to be higher. Do you agree? But this higher implies that I can consume more at time zero. I can save a little more, and saving a little more creates more consumption in period two. So that's why taxes are crucial. Taxes affect not only current consumption, but affects also future consumption. And remember, guys, that in real life, on economics, savings are not just going to the bank and just rest there. Remember that banks use that money to lend this money to investments, okay, or to other people to buy homes or to buy cars. And this consumption is basically the engine of the economy. Make sense to you? Okay, so that's what you can do here. So you're gonna be able to do this stuff, guys. Don't worry. I will show you how to. Okay, so now let's go another. This is an app. Take a look. Can you run this app, guys? Just run it. So basically, guys, this is another way of creating an app, but it provides me everything. It provides me here. I've done this one here to provide me what is my consumption, what is my future consumption, what is my maximum utility, and what is my optimal savings. Do you see? So better to have all the information in here so we can see what's going on. If I move, take a look, it's 40, 41. So let's move this to 10%. Do you see? I will consume 41, but what is going to happen is as soon as my R is higher, I will consume more in the future. This improves my utility, and my optimal saving doesn't change because the optimal savings depends on the disposable income. So the only way in which I can change my optimal savings is by moving, let's say, this one to 15. You see? If I move this to 15, now I will say 41 because I have more consumption now, 43. And saving more, this 41 times 10% interest rate, I can consume 49 in the future. Of course, I'm much better with a 7.400 in utility. Make sense, guys, to you? Are you able, can you run this one here and be sure that you are able to do this stuff? I need to be 100% sure, guys, that you are able to run and you are able to see what I'm showing to you, because you're going to be doing this stuff for your final too.
I'm good. I got it.
Perfect.
Yeah, mine worked.
Excellent. Okay, guys, excellent. So we are going to be able to do this stuff. You have examples here, but I will show you, as I mentioned to you, a very easy way to create all this stuff. Okay, so let me close. Now, finally, guys, I've created another model, and I want to show you some limitations of the way we do this stuff. So the ISLM model, guys, is a very, very important model in economics, you know. Let me move, give me 1 second, I will save this one here. So let me clean this one here. Okay, guys, the ISLM model. So I comes from investment, S savings, L is liquidity, and M money. So basically, it links real markets, production, etc., with financial markets. Oh, sorry, with monetary policy. Where's my mouse? With monetary policy. Okay, so the model is very straightforward, guys. It says simply production or income in a country is always going to be equal to the consumption plus my investment, and my investment depends on the interest rate. Okay, the higher the interest rate, the lower the investment. Okay, I invest less because it's more expensive to get money from the banks, plus the government expenditure. Okay, so if we assume that C, guys, normally this is assumed like that. It's C0 plus C1, 1 minus D. I will explain this in a minute. And my income, my investment is going to be my natural investment minus B times R. So this is what we do in economics, a very simple model. So this implies consumption, I need to consume yes or yes. So this is my natural consumption. Investment, the same. I need to invest yes or yes to maintain infrastructure, to maintain my business, etc. But what matters in your consumption is this part here. Do you see this part here, guys? What is this part here? This is my disposable income now. So my disposable income will depend on a fraction that I decide to consume. So if my disposable income, for example, is 10, and then my consumption, my marginal consumption is, let's say, 50%, okay, I will spend from my 10, I will spend 5 to consume. Make sense? So this BR here is basically R is simply my interest rate, and B is my sensitivity to interest rate. This one here, sensitivity to interest rate. So basically means how sensitive you are to increases on interest rate. You don't really care if the interest rates goes up. You care a lot. You care very, very few, but you don't care basically. So these are the conditions of Y. So if I replace all these equations here, guys, so this is 1, this is 2, this is 3. If I do 2 and 3 in 1, I will have the following equation. So C0 plus C1, 1 minus T, plus I0 minus BR plus G. Do you agree with me, guys? Do you agree?
Yep.
Okay, so the model is always composed by two things. So what we are going to be doing in the ISLM, guys, is going to be, here is my income, here's my production, national production, and here what I will have is my interest rate. Got it? And then what I will do is I will create my ISLM. It's going to be like supply and demand. You're going to see in a minute. And what I need is basically I need to have R in function of Y. Do you agree, guys? That's what I need to do. I need to have a function here, R in function of Y. So R is this one here can move in here. So it's going to be basically 1 over B. Agree with me or not? This is moving here. The B goes down. That multiplies, I will have C0. I will have I0. I will have government. So this is done. This is done. Then here I will have I comes as a negative number. So I will have I will have Y negative, this negative here, plus C Y minus T. Do you agree with me, guys? So this is the equation of interest rates for the ISLA model. This is for the IS. So I'm talking about the IS here. This is my IS. My LM function, guys, this is the monetary side of the equation. This is going to be my monetary side of the equation, guys, and the questions are very simple here. So what we're going to say is that I have the liquidity that is demanded by people. So the money that is demanded by people, okay, depends on the level of production or income and depends on the interest rate. And the simple model, guys, is simply K times Y minus HR. So basically, the liquidity, so the money that the people require increases if Y increases. Do you agree? If I start producing more, my liquidity needs are going to increase. So that's why it's positive. And this depends on K, okay? On K, that is simply the income sensitivity to money demand. This is income sensitivity to money demand. And this one here, obviously, is going to be the interest sensitivity to money demand. The demand. Okay, so what happens with R, guys? As soon as the interest rate starts increasing, the people require less money. They prefer to buy bonds, for example. So this implies that the money that is in circulation in the economy starts moving outside from circulation and moves into the bank because you are buying now bonds instead of having money, cash. Okay. And then the model, guys, is very straightforward. What we want is this is the monetary supply, money supply. And we divide this by P. This is prices. Okay. Basically, this is real. All this part here is called real money supply. How much money how much money I have to buy real products. And this one here is going to be equal to my liquidity function. So from here, guys, if I do the same stuff, I simply replace, and I want to have R in function of Y. So simply I do from here, my R is going to be equal to KY, move this minus MP divided by H. That's it. So in equilibrium, guys, what do we want? In equilibrium, so let's call RIS, RLM. So in equilibrium, guys, these two rates must be equal. So can you open your file now? Okay, 2 minutes to analyze and to check this. If you have questions, please ask me. This is a very simple model, but it's very powerful and very interesting model to understand the economy. So we have, for one side, the production side of the equation. We produce more, guys, if we consume more, if we have more investments, and if we have more government spending. You agree? Makes sense? So the consumption depends on basically one thing, that is the disposable income. So the lower the taxes, the more disposable income. So the more I consume, the more, I produce more. So in USA, guys, have you heard this saying that say that the engine of the economy in USA is consumption, private consumption? This is why. Okay, that's why the discussion of interest or taxes are crucial, because they say, okay, the larger the taxes, the lower the disposable income, the lower the consumption, the lower the consumption, the lower the production, the lower the production, the lower the hirings, the more the unemployment. Make sense to you? That's more or less the logic. Now, also production increases with investments. So the more I invest, the more the private people invest, the more the production becomes. Now, this investment depends on the interest rate that is present in the market. You can see here, if the interest rate increases by a lot, so this implies that my investments are going to decrease. Why? Because interests are cost of capital. So I need to pay more for a loan that I need to produce a factory. So the more the interest, I will produce less. I will build less. Make sense? So this is the general idea here. And G is a government expenditure. Makes sense to you guys? And monetary side of the equation is simply, I need money. The people needs money to trade, to transact, to save, etc. So on this, the requirement of money depends on two things. Depends on how much money you are producing, or you are making, you are generating. So the more you produce, okay, so you need more money. So that's why it's positive. But also the higher the interest rate, if you're an individual, the higher the interest rates, what you're going to be doing is preferring, instead of having cash, you're going to start buying bonds, for example. So this is going to decrease my liquidity in the market, liquidity in terms of money. And here, basically, we have the equations that should be equal in order to be in equilibrium. And that's exactly what your model is going to be doing. Can you please open your My ISLM and analyze for a couple of minutes, and then we run. 2 minutes, and then we run. Please be sure that you can run, because what I'm testing with you at this point is testing that you can run programs like this one. That you are able to create your 3D, that you are able to create apps, that you're able to create basically everything that I'm showing to you here.
I was able to run it.
Perfect. Everyone? So if I'm running this one here, well, I have my graph, I have my equilibrium. So my IS is the one that looks like the supply function, and the LM looks like the demand function. So basically my equilibrium is going to be K is going to be 113, and my interest rate is going to be 3.33. So this is what the central bankers do, guys. They try to find, well, more complex models than the ISLM, but the idea is, what is my optimal R in such a way that I will get my optimal Y, my optimal income. Make sense? That's it. Monetary policy is always driven by the interest rate. The Fed rates is called. And that's always the headache of the central banker. Make sense? Okay, so can you analyze the other one? My ISLM number 2. Can you take a look to what this does? If you realize this ISLM is not printing anything. What I want in the next one is to print the results in here in my command window, and I want to do a graph and plot my equilibrium, of course. 2 minutes to analyze this one here. You tell me, guys, when you are able to run and analyze and see what's going on. Can you make me a favor? Do you see my screen, right?
Yes. Yeah.
Okay, so what I want is change this to 1000. Instead of 2000, change it to 1000 and see what happens. Let's save it and let's run. Do you see this message here? F0, they don't cross each other. They don't cross the value 0. Remember, F0, we know this function. We have worked with this function, so you need to be able to read. So then, guys, when you have this type of issues, implies that basically your values here, the values of the definition of Y are not enough. Take a look to the graph. Do you see that? You see that these guys are going to intersect, but as soon as I have limited Y to be 1000, the program is not able to do that. Agree? So what is the normal solution? Well, see my graph. Oh, got it. I know what is the problem. Let's change this to 2000. So that's why I wanted to show you. So when you do something and the parameters don't satisfy the condition, so you need to start playing with the parameters or playing with the spaces or the space or the range for Y. Make sense? So now if we run this one here, now we get equilibrium. Why? Because the equilibrium is 1133 point something. And then I have here my income. My equilibrium income is this one here, and my equilibrium interest rate is this one here. Make sense? You are going to be able to read, to modify, to do whatever you want with this code here, guys. But let's go to another one. Where I am. Can you open the other file that is called ISLM dynamic app? Can you run this one here? I need to be sure that you're able to run. One minute to run, please.
I got it.
Perfect. So if we run this one here, take a look to what we are doing. Something similar, guys, that like we have done in the past. This is an app in which I can run shocks. So for example, let's do a shock on, and take a look to the graph, okay? So let's put this one here is 133, 3.33. So now let me do a shock. I will increase the government expenditures. G influences the IS curve. Sorry, yes, the IRS is going to be moving. Do you see? So if the government start increasing the expenditures, so basically what I will get is a higher X and a higher interest rate. Make sense? So I can do another shock. I can decrease my taxes. When I decrease my taxes also, what is going to happen is my ISLM is going to start increasing, etc. So you can do, and then you have here some results here, etc. Can you run the last program, guys? I want to start talking more about what you're going to be doing. Can you run the static one? Sorry, not the static, the dynamic one. ISLM dynamic app one. Just run and be sure that you are able to run it. The only difference that we have in this case, guys, is that I can export to CSV. Can you please open this one here and click on export? You do any shock. I'm sorry. Let's do increase on G, for example. Run shock. And then what I want is you to export to CSV. You tell me when you're there. Export to CSV and be sure that you can open your file. When you export, something like this is going to appear, where the results are being exported. Can you verify, guys, that you have saved your results? Save here.
Professor, I have a question.
Yes.
How do I change what folder it automatically gets saved to?
Oh, that's the issue. You need to, well, basically need to go to the file and change it manually. You can do that. Yeah, we can try to do this and check. So what we can do, normally this by default saves it here. Okay, so we need to change the defaults of this one here. Where is this one here? Where is my program? Here we go. So my export button. Yes, okay. Yeah, file name. What is my file name? temp directory? Here. This one here, where's my temp dir? The temp directory is that they use as the default, the one that appears in this small pop-up. What you can do here is write C, remember what we have done before? C users, whatever you want, etc., etc., etc. Sorry. And this goes, you replace this one here, basically in here, in temp direct, in the directory.
Got
Okay,
it.
guys. Okay.
Thank you.
Pleasure. So now, guys, we need to talk a little about your project. And to talk about your project, let me tell you something that happened to me. This was more or less 2022. I was doing, a big project. We had an art program that had around 50,000 lines of code. This program was made almost in 5 years, improving, and then finally we got a beautiful art project that was working fantastically. But the times were changing, and R was not as flexible as Python. Okay, so the project was, okay, we need to transfer this R into Python code. And I was working this with a colleague, and we said, this is going to take at least 1 year to do it, because we need to do very carefully. We need to do the optimizers. The Python optimizers are different. The way of writing a code in Python is different, etc. So we estimated more or less 1 year. This was more or less mid 2022, guys. And you know what appeared at mid 2022? Well, it was before that, but we pay attention to ChatGPT. Have you heard about ChatGPT? Of course, you have heard about ChatGPT. So what happens is that someone told us, hey, you know what? They are saying that ChatGPT is very good on things that you repeat, and coding is basically something that is well structured, and you repeat a lot the commands, the functions, etc. It's very well structured. And this was a perfect scenario for us for testing ChatGPT at the time, 2022. And so we said, okay, we were very skeptical in terms of how good can be ChatGPT and translating a 50,000 line code in R into Python. Okay, we did it. It took us more or less 5 minutes in translating everything. So we upload all our R code. Of course, we have a private environment. That is very cheap. We upload everything to a private environment, and we translate everything into Python code. And then, we were saying, oh, come on, it's not possible that in 5 minutes, this thing is doing something that we were supposed to do in 1 year. Okay, guys, real life, it took us 2 weeks to clean, organize, comment the results, and try to clean a little more, but the program was working beautifully. It was I blow my mind. I cannot believe it. I really cannot believe this stuff. And then I saw the power of ChatGPT, guys, once you understand what you want to do. Got it? And so that's why what I have done to you up to this point is to show you all the things that you can do. You know how to read, you know the commands, you know how to graph, you know how to optimize, you know how to use polynomials, you know how to use matrix algebra, you know all this stuff. Okay, so for you to read these type of things, it's going to be extremely simple. Got it? And so what is what you're going to be able to do in your proposal is going to be able to use ChatGPT. Okay, and what I want from you is a very detailed, high-level work, as I mentioned to you. So first of all, you need to select a model, an economic, financial preference, okay, model. You need to describe the model in words. Yeah, ChatGPT can do this for you. But what I want from you guys is you try to understand what the model is doing. I want to know, and I want to see equations. Okay, when I say equations, I want to see objective functions. I want to see restrictions. I want to see optimizations. Okay? And basically, I want to see some recommendations. This is a written part. So this part here, guys, is going to be in Word, a document in Word. And then what I need from you is I need to create your MATLAB file for the model that you have created. Okay. For this, I need an M file or M files. I need you to do, try to use data, can be Excel, can be market data, and then simply try to do what the model does. Okay, so this data, guys, is optional. So if your model is like the ones that I presented to you, I'm okay with that. But better if you can find, Yahoo Finance, for example, presents beautiful models and beautiful data. You can upload the data and then you can run the model. You can tell the model to run whatever you want. And then finally, I want a PPT, a PowerPoint showing your work. Very small, 5, 10 slides maximum. PowerPoint showing the theory, showing the model. Basically, some graphs, equations, etc. That's it. That's all what I want from you. So this is your final. And your deadline, guys, remember, is Monday, I think it's 30, right? At noon. Make sense? So create. Oh, yeah, wait a second, guys. Excel, you need to be sure, must work. So your program, guys, must work. Okay, let me show you. I created one example for you, a little more complex than ISLM that includes a balance of payments, so includes external markets. And let me show you what happens. I think where is this one here? So let me show you. This is the mathematics. So I want something like this. This is my model. This is my economic explanation. These are my equations. These are my optimal equations. The ISLMVP is markets, real markets, monetary markets, and external markets, foreign markets, exports and imports. So your equation, guys, is net exports. And then you have all the mathematics, etc., etc., etc. But I want to show you the following. Once we ask, okay, I understand the model, I know the equations, I know that I can optimize that. You ask, okay, now I want to create my code. Okay, so the code is going to be created for you. Let me close this stuff here. The code is going to be created by you. Oh yeah, sorry, one more thing. In MATLAB, it must work. You need to describe commands that are new. So for example, you are using one command, whatever, okay? Command XXXXX. You need to tell, oh, this command selects the data, organizes the data, filters the data. You need to explain that. So perhaps I have a new command in here. Can you open, can we open, guys, please, this one here, ISLMVP? You have this also. Let me see if there is a new command here that you can explain. No, we have interpolation. You know how to do that. You have F0. You know how to do that. Let me check if I have in here some command that is new. Plot. No, you have everything. You know everything. So perhaps in the dynamic model. Linspace, you know how to do linspace. I just want some command that is new. Yeah, right table. I show you how to use this one here in one of the videos that you have seen. Well, it doesn't matter. Imagine that you find a new command, this one here, for example. What is UI label? So what I want in an appendix of your Word, okay? Describe the commands. This should be as an appendix in Word document. Okay. Okay. So let's take a look to what happens with the ISLMVP. So you ask ChatGPT, okay, I like this model, please create the code. The code is going to be created. Okay, beautiful. The first problem you're going to find, guys, that I found here is that this was defined in 1000, the 1000 issue that we had. Okay, that's easy to solve. Oh, you say, oh, this is 1000 is not enough, let's do 2000. But take a look to what happens. Look, guys, you run this one here, and then you can see immediately, oh, this is not working really good. Not working. Why? Because all these lines should intersect in the same point. Do you agree? But apparently the values that that ChatGPT has proposed to you don't make sense. So what you are going to do, guys, where do I have this one? I saved it for you. So here we go. Give me 1 second. So this is the sequence that I've done for you today, guys. Take a look. Is this the one? Yes. So this is what I ask. I ask, okay, guys, give me this model. Give me the explanation of the ISLMVP. So this describes this one here beautifully. You can read, you can understand. Nice. Then I ask, okay, give me the code. The code that I gave you, that I showed you just a couple of minutes ago, is the code that is this code here. You simply copy, paste on the M file, and then you run your program. And then when you run your program, you realize, oops, there is something wrong. What is beautiful about ChatGPT, I'm sure you have used ChatGPT, right, guys? Perhaps not in this environment, but have you used this?
Yes.
Okay.
Yeah.
So it is natural language, LLMs. Okay. So what I ask, hey, wait a second. With the starting values, there is no common intersection. Please change starting values. That's what I'm telling MATLAB. Okay, MATLAB said, oh, sorry, blah, 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 and creates a new program. Now, this new program is, what I want from you also is this. So I want your first program, and if you're lucky enough, guys, the first run, it's it. But if you have a second program, I want you to do ISLMVP1. Okay, so what I want to see is the sequence of things that you have been doing, trying to optimize and trying to solve and trying to make your MATLAB to work. Okay, so they have changed the original starting points, blah, blah, blah. So run this stuff. And again, you continue having problems. Do you see that, guys? Then continue complaining with MATLAB. Sorry, this is not the one. Not MATLAB, complaining with a code. Still do not intersect. Make sense? And then it interacts a couple of times, etc., etc., etc. And then finally, guys, was not able to solve the issue. Okay? Was not able to solve the issue just by changing parameters. Was not able to do that. And what's interesting, guys, it was testing the results. They say, oh, the results have been tested using Python. Somewhere, I was really, really interested when they say, I tested the results, and the results were tested with using a Python code. It didn't work. Okay, it didn't work. Then what I told them, okay, you know what? Do something with the program to work. And basically what these guys have done is they have estimated more or less, you know, the coefficients, if you, the Y star at 500 and R at 5, more or less can produce, most likely will produce a result. So if they give you the code, you do the code. This is the code VP number 2. Just run this code, and then you can see. I think I have had at least 6 iterations to arrive to this point here. And then I changed a new code, and I provided MATLAB, sorry, not MATLAB, ChatGPT. Now I told him, okay, yeah, that sounds cool, but now I want to find, improve the code, blah, 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 that's okay. What is this one here? Yeah, the problem, you see, this is a no interaction. They will say, oh, I found it. And then when you run, nothing. It didn't work. Until you do this stuff, 505. Okay, so it worked. Yeah, all the values are provided here. But then I say, you know what? I want the program to have the correct parameters values, not fixing Y and R. And this was very interesting. It took the computer just to run this stuff. It took more or less 5 minutes. And they told me, okay, with this, you should be able to find it. No, it didn't work. It's still not correct. You see? And then this is what is very beautiful. ChatGPT started testing different values. So they say, okay, if my income is this money, I get an interest rate of negative 25, not correct. And they start playing. Another value. If the income is this value, this should be my interest rate, not correct because it's negative, etc. And it starts doing a lot of things, guys. And then finally, they give you they didn't give you a solution. It gives you a range. They tell you, hey, guys, you know what? If Y is between 400 and 900, you can find a solution. If R is between 2 and 8, you can find a solution. Got it? And then what I have done is basically I told MATLAB, I told these guys, okay, you know what? I want the equilibrium at these points. Do we have an equilibrium at this point? It was randomly selected from this interval. Then ChatGPT created a value, created a program, and the residual, yes, so it was not able to find anything. Okay, it was not able to find a realistic equilibrium, etc. And then I told them, okay, you know what? Now I'm forcing the model to take these values. Are you able to find a solution? And these values are the ones that are presented here. This is the last model that I'm showing to you, BP3. If you run this one here, you see, indeed, I have found an equilibrium. At least what ChatGPT has done, it was not able manually not manually, by itself to find an equilibrium, but given me the intervals, they should be between 300 and 900 or something like that, and your one should be between 3 and 8. Give me a lot of information to create my equilibrium. Do you see? And so that's what I want from you. So if you're lucky enough, you're going to have one single round. But if your model is a little complex, and I would like you to do, guys, kind of not simple models, but a little complex models that are interesting for you, that can be something that you want to be using in time, and is going to be able to give you a good grade in the class. Make sense to everyone?
Yeah.
Okay, so that's it. So now I will have, I need to hear from you guys. Let's say 5 minutes, ideas that you have. I need to take some notes so I can tell you guys, this is too easy. Oh, that's so too complex, or change or look for ideas. So, and everyone is going to be able to participate and to comment on the ideas of your friends. Okay, make sense? So
Yeah.
allow me to, let me save this one. Okay, who wants to be first? It's not an exam, it's nothing. It's just simply say what are you planning to do? Who wants to start?
I can go.
Okay, Luisa.
Yeah. So
I'm doing a double master's in data science and
Beautiful.
economics.
Yep.
And for my capstone, I did something related to behavior economics,
Oh, beautiful. Uh-huh.
where I looked at consumer behavior in an e-commerce platform.
Beautiful. Yep.
So what I thought about doing was first just implement the Cobb-Douglas utility function, a budget constraint,
Mm-hmm.
and try to understand how the user would um, what the user would purchase using the utility maximization
Mm-hmm.
model. And then I thought about doing something more intricate, trying to simulate the consumer choices, trying to put some machine learning in that, but I don't
Beautiful.
know
Yeah.
yet how I'm gonna do that.
No. But not even if you do machine learning, what you can do is you can try to simulate the behavior of individuals. Okay.
Okay.
When you do behavioral finance, you have the famous Kahneman and Tversky mathematical models on risk aversion, right?
Mm-hmm.
You can use type of risk aversion, but there is also a lot of models in preferences. So take a look to consumer preferences,
Okay.
and there are a lot of models on consumer preferences. One of the things that you can do also is now that we are going to have the Amazon, how do you call the Amazon Black Fridays? They not call Monday. How do you call it?
Cyber Monday?
Cyber Monday, for example. So, what are the consumer preferences to go to Cyber Monday? What the consumers are going to be buying the most? That can be really interesting. It's up to you, but this behavioral economics is really interesting. You have a lot of models in behavioral economics. Just go around and just type, you know what? I want to see what is the behavior of consumers and e-commerce with MATLAB code. Want to maximize
Mhm.
utility, and I want to create a model for consumer preferences versus, I don't know, buying on discount versus buying on at any other time, something like that. Because
Okay.
this is good. This is good.
Okay, good.
Good, good,
Thank
good.
you.
Yep, perfect.
I can go next. Um, I am getting my
Julia.
master's part-time, and my full-time job, I work in renewable energy. Uh,
Oh, yeah.
so I was thinking of doing something with the levelized cost of energy model,
Yep.
um, and maybe look at like project level economics for a specific portfolio of renewable energy projects. So looking at all the different factors that will affect the output and the costs that go into it.
Perfect. This is nice. This is really nice. Yeah, renewable energy, guys, is hot topic now. Do you agree? So we're going definitely there. Okay, Julia, I think that this is a perfect scenario.
Cool. Thank you.
Yeah, yeah, that's good. You know what? Anything that you can use from your knowledge in your work, please apply that. And remember, if you can do something that is going to be useful for you, much better.
Okay. Sounds
Okay,
good.
perfect. Who goes next?
I can go next. I'm a PhD student in economics, and so I would like to do something that works with what I just finished in macro too. So I'd like to do an OLG model, like a diamond OLG with bonds and taxes. And it doesn't
Beautiful.
have to be with bonds and taxes, but I just would like to do something that is going to be applicable to what I learned last semester and see what that looks like in MATLAB, since we didn't get to do that.
Beautiful. You know what? This is one of the things that MATLAB can do. You can do an intertemporal type of intergenerational model with I have done several OLGs in the past, and MATLAB is amazing doing that. And I did this by hand. So now that you have ChatGPT, I'm more than happy to see how ChatGPT is able to model this stuff here.
Do you have any recommendations on how many kind of like parameters I add in? I mean, I don't want to make it too
No, no,
complex. I
no.
figured bonds and taxes is good. I
That
mean, if
that's
I can,
yeah. Go ahead.
I mean, I feel like it would be interesting to have kind of like a neoclassical growth model in there as
Yeah,
well.
I agree.
But I don't know if that's going to be too complex for me to do in MATLAB initially. Do you have a recommendation?
You know what I recommend to you?
Yeah.
I have been using coding with ChatGPT for almost 2 and 3 years and very complex programs. Okay, the thing is that it has a lot of limitations, as I have shown you with ISLM BP. It is a simplified model, but the thing is that it had troubles. However, what I have realized also is that sometimes you can be very lucky and the program runs immediately. So what I suggest you is do a complex model. Then if you fight with the model like I've done, do several iterations until you try to find something. And if you are not able to find something, then you start simplifying. Make sense?
Got it. Okay, great.
Okay.
Thank you.
And do it, because neoclassical models are very well developed. So there are a lot of coding in the cloud. Because remember, ChatGPT guys does simply look around and see what is there, and then tries to put everything in terms of what you're looking for. Okay, so the model or the OLG models are easy. They not easy, but they are very famous. Okay, very different variations of this type of models. And then if you put on top of that a neoclassical model to help you better understand macro tool project, this is perfect. I'm pretty sure this is gonna be the model is gonna be able to do that. Good.
Great. Thank you.
Sorry, you're a PhD economist, so you what year are you?
I'm a first year. I just took my comp, so I've still got a good another 5 years to go probably.
Oh, got it. Yeah, welcome to economics. The PhD. Yeah, I
Thank
never
you.
realized that you were a PhD. This is perfect. We need PhD
Thank
students.
you.
This is great.
I'm
Welcome.
quiet and stealthy, what can I say?
This is good. Yeah, the later we can join this with finance. You're gonna see how beautiful it works. Okay, thank you, Anna. So now we go, Simon.
Yeah, so I don't have a clear idea about my project yet. I'm a
Yep,
student of Masters of Data Science and Quant Economics.
yep,
And I was thinking about maybe doing something. I work a lot with AI. So
yep.
maybe doing something AI related, cost related of AI.
You
I
know
don't
what can
know
be
yet.
can be really interesting with
Yeah.
AI, and you know I'm trying to look into that space now. Is price discrimination.
Oh,
So let
okay.
me tell you how this works. It is a hot spot also, discrimination. So this works. Remember, price discrimination is usually applied in real life. Do you know what? Give me one example when someone uses price discrimination, guys. Something that we always use. What is that? Simona, you're traveling, right? In a week, little less than a week. What do you use?
Yeah,
What do you use? A plane.
I don't understand.
Do you agree? The most fantastic guys doing price discrimination, guys, are airlines. And price discrimination is getting so sophisticated now. That is amazing. Before in my times, I worked in the airline industry for 1999, 2002. I was, I know it you well, perhaps you were not even born. Continental Airlines, have you heard about them?
Yeah.
Yes, Continental Airlines was separated from United. So actually, it was very interesting. Continental Airlines bought United Airlines. The thing is that they used the name of United, they kept the name of United and simply disregarded the name of Continental Airlines. So at that time, I was managing all the business from Latin America. So I managed from Mexico down to Tierra del Fuego in Chile and Argentina. And price discrimination was very interesting. At the time, we had online services, of course, but the people didn't want to use the credit card. It's not like the e-commerce now that you are very safe using your credit card. At the time, everyone was afraid of someone stealing the information and stealing their money, etc. So it was very challenging to do price discrimination. But now, guys, price discrimination is one of the things that everyone is doing. You know that is really important for optimization of my budget. So if you use AI, so what you price discrimination is basically trying to maximize the use of your plane. Do you agree? So you don't want to have empty spaces. You want to have all the spaces filled up, okay, etc. So this is a very, very nice application of price discrimination, of AI, if you want to. But there are many other applications of AI, guys. Whatever, you can do portfolio optimization with AI if you want to. Portfolio selection and optimization. There is another one that I'm hearing a lot, and it's very interesting. Is do you remember if you go to a store, guys? Okay, you have the aisles in the store, and then imagine here you have, I don't know, Colgate. What else do you have? Colgate. What is another brand? Jesus, I'm tired now. I don't think.
Press.
Yes, Crest, etc. So you have a bunch of them. So how do you put them? Do you want to put them at the middle of the aisle? Do you want to put on top? You want to put them on the bottom? Do you want to put this at the beginning or at the end of the aisle, etc.? So this is something really interesting that the people is also using AI. Now, is trying to find how you are going to optimize your revenues by moving the location of your product. Do you see? And you have a lot of things with AI, Simon. It's perfect, and MATLAB is improving a lot with AI. So you're gonna see that. You have deep learning processes. There are fantastic processes now embedded on MATLAB, and then whatever you can do this.
Okay, thank you.
Okay. If you have questions, just let me know. Okay, guys. So I think that we have one student that is in Spain that I need to talk with her later, but we are in good shape. Okay, guys. So we have the deadline. Oh yeah, guys. If you can do you remember why I show you the sliders and all this stuff? If you can add, please. Yeah, I forgot to give me 1 second. That's why I show it to you. Let me tell you, this is this is, what is this one? Let me open this one here. So, guys, if you can use in your program, because this is really cool for simulation, all this stuff, sliders, apps, just to show. Do you remember what we have done in class? And I'm sure you can do that because if you have been able to run what I have done, you are able to create them too. So if you have a model with parameters, I would love to see what happens if I change this parameter value. What happens if I change these 2 parameters? How the optimal changes, etc. Make sense? This is also good for you because you're going to understand what you're doing. Okay, guys, questions?
I have a question, but it's not related to the project.
Yes, Anna. Oh, so we can stay after if you don't have more questions, guys, from the class, we're ready to go, and I just stay with Anna to chat.
I have a quick question,
Yeah,
Professor.
go ahead.
So if I want to use data, but I
Yes.
can't find anywhere that has the exact data that I want to test on, am I allowed to like ask ChatGPT and try to ask him to like create a data set for me?
Yes, and you just need to be very careful when you describe this in a word.
Yeah.
Everything that you do with ChatGPT, you need to tell me, this is what I've done with ChatGPT, this is what ChatGPT is telling to me, etc., etc., etc. Okay. So remember, guys, before 2023, these projects were done by hand. So it took almost, and the level of complexity of the models were very, very, very low. Now, what I'm trying to do with you is trying to push you into more complex models. So you don't spend a lot of time on typing every single line of code, but you need to spend time on understanding and solving issues that you have with ChatGPT. You need to give me something that works. Okay, so that's the main condition, guys. Don't give me something that is not working. You need to work, and after several iterations, guys, you're gonna find a solution. You need to observe the graphs. You need to see. That's why when I say do the sliders, it helps you see more or less what is the range of my values. What values are crazy? We're never gonna find a solution to that, etc. Yes, and if you are not able to find data, yes, you can do simulated data for sure.
Thank you.
Pleasure. Okay, guys. So see you, no see you. Send me your documents on Monday because I need to start. I need at least a couple of days to check your projects, and then I will post the grades on Wednesday next week.
Okay, thank you, Professor.
Okay. See you
Okay,
guys.
thank you.
Take care. Have a good
See
night.
you. Thank
See
you.
you. Bye bye.
Hey, so my
Hey,
question
Anna. Yeah.
that I have is, so I use latex like a ton, and every time that I have tried to like convert, so I have just to put in context here, I have R and R Studio downloaded
Yeah.
on my laptop, and every time I try to, I wrote a program to convert anything I do in MATLAB to latex.
Yes.
And when I do that, it automatically, when I go to the .text file, it automatically opens it up in RStudio. Now, I write my latex code using Overleaf, which is like
Yeah.
a online platform.
Mhm.
But when it gets converted into RStudio, I can't get anything. I can't get the program itself to run in RStudio.
Yeah.
And I don't know if you're the right person to ask. I just don't know what I'm doing wrong. I haven't used R. I've used Stata a ton.
Yes.
And I'm less familiar with R.
Mhm.
And I just don't know why the program, when it gets uploaded into RStudio, it won't run anything. And I don't know if that's because the language is written in MATLAB and it's opening it in as latex. Do you understand what I'm
Yeah,
saying?
yeah, no. But why are you doing this into why are you doing the intermediate step into LaTeX and then so MATLAB, LaTeX are why are you doing that?
Well, so I like having everything in latex visually.
Okay, yeah,
That
yeah,
so
okay.
that's part of it. Um, and so I'd like to have that. I've been creating these like kind of like these reference sheets for myself.
Yes.
Um, and so I just like the way visually it looks in latex.
No. I understand that, but one thing is to write it in LaTeX. LaTeX is like it's an editor. At the end of the day, you have
Yeah.
a PDF document or whatever. But the thing is that I agree with you transferring this into LaTeX, MATLAB LaTeX. That's okay, and you can just assume this is an R program. But there is a way in which you can translate MATLAB directly into R, and for sure it's going to work. I've done that. And
Okay.
the one that I use is ChatGPT. It's very simple. You upload your file into. I think you need to have the paid version. I don't know if economics has the paid version of that.
Okay.
You
I
know,
can
it's
I
straightforward. It's simply upload your program in MATLAB and then tell ChatGPT, please transfer this into R, ready to be ready in R Studio.
okay, I see.
And
Okay.
directly, forget about the LaTeX. The LaTeX is for reading. What I believe is
Okay.
what R is getting confused because LaTeX has different commands for different ways of writing something that are not going to be read by R. You know,
Yeah. Yeah, and that's kind of what I was running into was
no,
that I didn't understand that once I made it into a .text file, it
yes,
would automatically open it up in
of course,
RStudio. And
but it
I'm
doesn't
like,
work.
it doesn't work. And I
No,
didn't know if that was just me doing something
no, no, no,
wrong.
no, no,
Okay, that
no,
makes
no,
me feel
no.
slightly better.
No. The issue is that LaTeX has different commands for writing equations, for example.
Yeah.
Or commenting some stuff. I don't remember if LaTeX comments with a number or with a percentage signs. I don't remember that. But just a small change on just a small thing in LaTeX that is not recognized by R, R is going to collapse. It's not going to do anything.
Okay.
Not
Okay,
going to
got
do
it.
anything.
All right, cool. I just wasn't sure if I was missing something or not, and I've been trying to play around with it a bit, and I'm like,
No.
man, I feel like I'm genuinely doing something wrong here because it seemed so odd to me that it just would automatically open up in RStudio, but then I couldn't get it to run, and I'm like, this doesn't feel right. And you're right, it's the dollar sign that latex
Yeah.
uses, not the percentage. So
No.
I
Do
figured
it
I'd just
MATLAB
ask.
R.
Okay, cool. I figured I'd
Okay.
just ask because I was like, man, maybe somebody else
Yeah, of
will, maybe
course.
you'll know. So
No problem.
cool. Okay, awesome. Thank
Okay,
you. I
Anna. See
appreciate
you
it.
later then. Take care.
All right, see ya.
Bye
Bye.
bye. See you.